me go ahead and get started then.
I'm that excited.
Yeah, we almost answered it. So today we're going to talk about quad trees, which are similar to binary trees, except for a binary tree has 2 children. Therefore, a quad is going to have
4.
Did everyone get that? Everyone got that?
Yeah.
Yay.
All right, good.
Is that the hard part?
Sure.
Sure.
I had to choose another data structure, so sure, we'll choose quad trees. They're used
Let's go
to.
back to arrays. Let's go back to arrays.
But we already did arrays.
Do it again.
Is there nothing else in the STL we can learn?
Well, there's plenty of things we can learn. Is there anything useful in the STL that we can learn? That's the real question.
What's the answer to that question?
Well, it depends on what your opinion of the STL is. And since mine
I
is
like
trash, the answer is no.
I like the STL.
Good.
It makes things easier and a lot less complicated to read.
How about debugging them?
Hmm?
How about debugging?
I don't
Standard.
usually have too much debugging compared to when I'm just trying to do things on my own.
I don't think we should heavily rely on it, but I think it's a useful tool.
It's the templated part I don't like.
That's but I can get over it.
I just hate templates in general. So.
Templates in general?
Yeah.
Well, I'm sure they hate you too.
Yeah, they probably do.
They send me emails. Can you get Emily off our back? All right, so yeah, quad tree. But before we start talking about quad tree, let's go talk about at least some type of use case that makes sense. So a range query is a search in a directory in which the exact key may not be entirely specified. Well, that's a fun definition. What?
Directory?
Dictionary. Whatever.
Same thing.
Start with a D, I, C, T. Yeah. Range queries are primary interfaces with multi-dimensional data structures. Whee! So here's some 2-dimensional ones. So your key may be the red square, and they want to know how many dots are in the red square. All right, class, how many dots are in the red square? How about the green? And by square, I mean rectangle, because that's totally not square. One. How about is that a blue circle?
Yes. Why is it 1 dot purple?
Because it's shared between the red and the blue.
Oh. Ooh.
Look at this genius over here.
He knows his colors.
I can use deductive reasoning.
Yeah, I can barely see colors, so.
Are you colorblind?
No, just these. I can barely
The
see
red looks
these
brown.
colors.
I like to tell people I can't see red
Why?
because they always put their important information in bright red. So if I tell someone I can't see red and then I forget the important information, it's a perfect alibi, right? I can't see red. Why'd you put in red? Yeah.
You didn't see anything.
I didn't see anything. So if we're going to query on a 1 dimension, okay, you just have X, then it's just how many dots are in this line. All right, that's kind of boring, I think. Of course, that implies the rest of this is going to be amazing, but we'll get to that. Now, you can actually store this as a binary search tree. Why would we want to do this?
It takes less time to search.
Okay.
To organize it. Maybe we should ask that guy.
I think we need to ask the login why we want to have a binary search tree. All right, so how quickly how long does it take to find the, what was it, the 2 points on this line? I'm sorry, let me rephrase that differently. How long does it take to find the starting node and the ending node of the list of all the numbers in this range?
If it's
The starting and ending? I think that's
sorted, then you should be able to find out easier.
Right, well it is sorted because it's a binary search tree, right?
From this example, I think O of n.
Well, to find this one is O of log n because it's a binary search tree, right?
Oh,
Boom.
wait, because adding, okay. Yeah, it's
And then find this one, binary search tree is O of log n. So to find the two endpoints is log of n. Bless you. But if you're keeping it as an array, unsorted, then it would take O of n. All right, this isn't too impressive. So we could try and do a binary search tree in 2 dimensions. Does this look good?
No.
It looks terrible, doesn't it?
Sadness.
It is garbage. So instead, we're going to have what's called a quad tree. So instead of splitting it in left and right, we're going to split it into 4 quadrants because it's 2 dimensions.
Oh, it's like a spider web.
What?
Because there's a middle, and then you're just going to go out from it instead of it coming down.
Oh, okay. Yes. Yes.
Or like a flower or something.
Okay. Yeah.
Quad flower. Quad flower.
So the root is going to look like that over there, although it's going to be flipped because for some reason not for some reason. In computer science, 0, 0 is in the upper left. Always.
Why?
Oh yes, we'll go ahead and talk about that. So
They
back.
screw it up from math.
Hmm?
Because that's the way math does it. Because of the different quadrants. So why would
Well,
they
math
screw
is
it up?
wrong.
Then we should tell them we don't have to take it. Oof.
That's
You
a
were
dangerous
wrong.
road you go in there.
I'm okay with this.
So we all have this thing called a monitor, right?
Mm-hmm.
Right, and it displays characters. And you know, back in the old days, after typewriters, but before the 90s, you know, your cursor would be right here, right?
Mm-hmm.
And you go blink, 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 and then you type something, and you go back, and you go back, and go back. And then put your cursor right here. Well, if that's the way your screen works, where's the beginning? Upper left. So 0, 0 is up here. And when you scroll, you're actually shifting the page up. Think about it as you have a piece of paper. You don't start writing your report in the bottom left and go up. You write it from the top left and go down, right? So, that's why 0, 0 is in the upper left. And we got that? By the way, before we had these terminals, they would actually print it on a piece of paper, and that prints in the upper left going down. So yes, the upper left is the beginning, 0, 0. Of course, that implies that this is negative over here, but I guess we won't get to that. Never have that problem. But if you ever do OpenGL, you can move 0, 0 down here if you really want to. Have fun with that. All right. So, quick rule. Every quadrant in this example may only have one node. And for what we're going to use, that's probably the easiest way to go about it. And so let's go take a look at this picture. The root, let me jump back. The root node, of course, has 4 children, 1, 2, 3, 4. And when you begin, there's nothing in them. So this still has the root, and just as A, this one has just the root and has G. This guy over here, since we added B, we would have to split on these 4. And then if we added C, since it would also be in this node, we had to split again on those 4.
I don't like it.
So
What do you
the
not like
first
about it?
initial
I don't like the
node-
picture.
You don't like pictures?
No, I don't like that picture.
You want a different picture?
Yeah.
You really want me to give you a different picture?
No.
I can give you a different picture.
I don't know about you.
Are you sure? I can give you a different picture. I have different pictures. You watch. You asked. You asked for it.
The genie is out. You cannot put it back in.
Can I make my wish to get at least past this class?
What?
If the genie's
I
out of the
regret
bottle,
it.
I regret it.
So we have agenda. So here's another
I
picture.
regret it. This is all your fault.
Let's go back.
What about this picture? I like this picture. This is a good. This is a good picture.
Hey,
This
that one
actually looks
makes
super
sense.
interesting.
This is a real good picture.
Like, I don't understand any of it, but it looks super interesting.
See, the root node contains 4 children of
Oh,
those
I
4,
get it.
and then this guy has those 4 blocks down there.
I get it. I get
Isn't that a
it.
nice picture?
I like
And
that
then
picture.
you know what they do that I always think they should never do? Let's show the pictures of the people who invented this.
Why?
I don't know.
Ooh.
Let's see, definitions. Look at that old picture. There's some other guys.
Robert
How do you say that first name?
Hannon.
Okay. All right.
What's this? What was that last one?
Oh, that's a. So there's different types of quad trees. I'm trying to do the simplest one.
Okay, let's not. Okay, that's fine.
I like this picture now.
All right. You like this picture now?
Yeah.
Oh, okay.
Oh, I like that one. The
Wait.
little boxes. No points with the little boxes. That was a good picture. So coming from the root, there's the 4 different quad nodes, and then after that, everything has 4 children.
Mm-hmm. Only the leaf can actually contain the node. In this implementation of a quad tree.
Which one's the leaf again?
Which one's what?
Which one's the leaf?
The ones at the end
Oh,
of the tree. You know, at the very end of the tree, there's leaves.
so those are nodes.
No, they're all nodes, but only the leaves contain the actual. Whoa. Wait, hold on. I'm sorry. Only the leaves contain the actual node or the data, aka A, B, C, D, E, F,
Oh, I
G.
get what you're trying to say.
Hmm?
I get what you're trying to say. So there's nothing in the other one?
Yeah, so this node doesn't actually contain the element. Maybe I should call them elements. Or the point. In this implementation of a quad tree, only the leaves contain the elements.
They're just pointers.
Right.
That feels like a waste of space.
Hmm.
No,
I did notice that about your ethics paper. Y'all use the F word quite a lot. Do they teach you that in high school?
What's the F? Like, which F word do you refer to?
Feel?
Feel? No. I wasn't allowed
I can't
to
feel
use
feelings.
I think in English
Exactly.
you're allowed to use that sometimes.
You do?
To like explain your side, I think.
Whenever anyone says that, I can only think of, Lord.
It's like saying my opinion is, but instead of saying
Well, that's just as at least my opinion is at least you recognizing that you just said something meaningless. When you say I'm feeling, it's like, oh, let's have an emotional argument. No.
I probably did that. When are those gonna be great? Yeah.
I'm halfway through them.
So your wife's not doing it?
No, she's helping. I'm doing some.
She didn't want to help, though.
Yeah. I told you that the first time I asked you. She's like, "There's no way I could help you. This is college grade papers." I'm like,
Excuse you.
this is computer science." And she's like, reads 2 sentences, like, "Oh, these poor students. Who taught these students?"
Exactly.
Like, yeah, it's pretty bad. Yeah, so, in high school, did they teach you to put the word feel in all your papers?
No, we weren't allowed Not to, but I exactly. did it anyway in this class.
What's that?
I avoid my feelings as much as possible. Of course not.
I never use that word.
Excellent, thank you.
I think I moved
She
that
said she
up
feels
over
like
here
crying
if I-
all the time.
Well, that's us talking out loud.
I'm not good with words. I have a small vocabulary.
I'm not good with words. What was it, the Go Upper 5? The Saturn V rocket, right? There's a beautiful XKCD where he explains everything about the Saturn V rocket using only the, 10,000 most used words in the English dictionary? Or maybe it was 1,000.
Oh, that's great.
So it's the Go Upper 5. And it was like, and I think it pointed to the fuel and it said, if this leak fuel, you will not be going to space today.
True statement.
Yes.
That's exactly what I would put. If leaky, do not go.
The Go Upper. Because it couldn't say the word Saturn. It must have been the 1,000 words, because Saturn didn't make the cut. So it's the go upper 5. All right, building a quad tree. So your tree or your box. Oh, by the way, why would we want to organize things like this?
Because someone thought it made sense.
All right, good. Let's keep going. We'll get to that later.
Why is that note
If you
like
have
in the
a
middle?
big group.
That's just to show you where the whole thing is, but the point is right there, which is clearly in this quad.
Okay, I was about to say, are the quads sharing the node?
No, there's no sharing.
Good.
Sharing isn't caring.
Yeah.
Oh, okay.
Well, I mean, if sharing is caring, then whenever you get sick, you should come to class.
I did, so.
See, thank you.
Feel it,
They
feel
taught
it.
you well.
Hey, stay here.
All right, so we have a quad tree, but unfortunately, the quadrants have more than one point. So let's chop it up. Oh, that was a quick chop.
I
What?
don't like it.
Okay.
What?
We decided to put the dots
They're
in those
not
like
like,
spots.
yeah, they're not like clearly one quadrant, which hurts me.
They have,
Why do y'all complain? All right, so we got a point right here. So obviously in this quadrant.
Okay.
Then we chop it up here. Uh-oh, that didn't fit her nicely, so we gotta chop it up again.
eh.
And then we continue on. I don't know why those arrows are there. Oh, I know why those arrows are there.
They're the point.
Because the root is technically right here with these are the 4 quadrants. And then this arrow points to this next node, which is these 4 quadrants. This root points, that arrow points to that node, which are these 4 quadrants, which points to that node, which are these 4 quadrants. How are we doing?
So all 4 quadrants together are a node.
Yes.
Okay.
And we're back to this example. Beautiful.
Issues, yes.
So if you put all the nodes in one quadrant, usually not a problem, but what's the big O here? It's log base 1 divided by the minimum distance between nodes.
Okay. Nope. He's not gonna say that.
Well, they didn't say anything. What do you think the big O of a quad tree is, by the way, to find something?
It depends.
On if it's balanced.
We'll say it's relatively balanced.
Is there a way to divide log of n by 2 or something? Is it?
Well, in binary tree, you cut out a half of each time, and it became log base 2.
Oh.
So in this one,
Log 4?
it's log base 4!
I got it.
Everyone got that? It's like, the B trees where you get to create the different, subscript, except for this time we're setting the subscript to 4. All right, 2D range query. So if you want everything in this box, then you can quickly figure out which nodes matter. That's the point.
Why did the arrows go back?
It's finding everything in that square.
Well, the square is clearly contained within these,
So is that
well, this rectangle is clearly contained within this rectangle.
child of the root?
So you have to check, you have to check all the nodes here. So you can ignore all of these points because they're going to be outside the quadrant. That matters. Come on, guys. What do you think an application of this is?
Awful.
What?
Awful.
So just the red box?
It's not for this one specifically, but we mentioned that it was for collision detection in video games.
Yeah, so this is a lot of times how collision detection is done in video games. It's going to be a different type of quad tree that's a little more complex. But this is the general idea. Because you keep all your points here in the quad tree and they move around. And then when you need to do it,
Closer to it, then
yeah, and then when you need to do a collision detection, you just find the bounding box and then you ask the quad tree, are there any points within this bounding box?
smart.
And that's log base 4. Let's see, the insert example. All right, if you find a spot where the node should go, then you're good. Yeah, so in this example, this was already split up. X was over there, so you just want jump, jump, jump. Here's the X. Woot. On the other hand, Oh, we're deleting? What are we deleting?
That was insert.
X.
This one's delete.
Oh.
But what are we deleting?
This is insert. This
Oh, we're
is
deleting C. What?
confused. Okay, go back.
Oh, yeah. So since we're deleting C, we don't need all this. So we delete all these nodes and
Oh.
then send the arrow just to go to B. Ooh, that looks painful.
We're gonna have to do that for the lab, aren't we?
That's a good question. I don't know. We'll find out. Nearest neighbor. Oh.
Oh,
I don't like that.
And then. Oh, that's it. Okay, great.
How
Let's.
many tractions?
How many what?
It said how many tractions?
Well, this was an algorithms course.